Hi, we're Team Fantastic 4-Bar, and over the past several weeks, our team has been working with using the engineering design process to come up with a really interesting solution to the ME2110 final design competition.
Now, our robot centers around the use of a 4-bar mechanism. Many of the teams use to design a lever mechanism to place the flag over the top. Instead, we want to go for a more reliable and more rigid system. That's why we chose the 4-bar. Now, we manufactured this for 4-bar links using the laser cutter. We also utilize the lathes to machine downward bushings in order to allow for a smooth extension and ingression. Additionally, we bought these polymer gears in order to gear reduce the motor, in order to not over torque it. And lastly, this 4-bar functions as two subsystems of one. It places a flag, but it also has a pin in the rear, so when it lifts up, it lets the system deploy.
Moving on to the rock clearing system, we have 3 modified mousetraps with zip ties and paint stirrers added to the end. 2 of the mousetraps are tied to a metal bracket that is attached to the 3rd mousetrap, so when the piston is activated, it sets off all 3 mousetraps at once to climb all the rocks.
And for the decoy deployment mechanism, on the front of our machine, we have aluminum 80-20 extrusion slots to accommodate the variations in tracks for both the long arm switch in the front and the PVC pipe, so we can adjust it to whatever height we'd like it to be. And also, once the inner frame of our mechanism reaches the center of the track, the long arm switch has to be hit twice in order for the balls to deploy for redundancy.
In addition to all of these engineering design considerations we've put into the machine, our team has had a holistic goal of making this device as clean and as well built as possible. You can see this by the choice of a high quality hardwood used throughout the frame. In addition, a high quality wiring and pneumatic harness that was designed and placed throughout. Most teams will be using plug connections when interfacing with their mechatronics components. However, these offer very little strain relief and can easily be pulled out during the competition. Instead, we opted for a terminal block approach. With terminal blocks, you can pull on the wires as hard as you want, and due to the rigid connections, they will not come loose. Again, on the note of maximizing strain relief on components, we decided to opt for these high-quality compression fittings instead of your standard press fittings that were supplied with the mechatronics kit. These high-quality compression fittings not only offer strain relief, but also help minimize leaks in high-quality pneumatic environments.
Another really nice feature of our robot is that we have 2 modes. We have go fast and go slow, and this pertains to the 4-bar and the placing of the flag. Now, we can control this through a toggle switch in the rear. When it is up, once the machine has deployed to the center and go fast, it will immediately go ahead and place the flag. Now, when it's in the slow mode, once it deploys to the center, it will wait a few seconds and then go for that Zone 1 flag plant.
In addition to this human interface element, we also have 2 more elements which are worth noting. The first is a reset button attached to the MyRio. By pressing this button, the 4-bar linkage will slowly return to its initial position, allowing for the device to be easily reset for future competitions. The second input device, which pertains to the 4-bar linkage again, is what's known as a positive stop switch at the very front. This allows the full extension of the 4-bar linkage to stop at a predetermined location, making it mechanically sound and mechanically consistent every time the device extends. My name is Max Kerner.
I'm Aaron Clegg.
I'm Kristen Thomas.
And I'm Natalie Rollingham.
And we're Team Fantastic 4-Bar, signing out.